Okay. Hopefully we're back. It appears that we're back, as far as I can tell on my end. Can someone put something in chat, please? Excellent. Thank you, Jacqueline. All right. At least now my computer makes a sound when I disconnect. It wasn't always that way. I think the issue was when I upgraded from Windows 7 to Windows 10. Windows 10 actually makes a sound when I do that, so it's nice to have that alert going off right next to me. Anyway, so I don't just keep talking and not know that I'm disconnected. That would be bad. Anyway, so we go back. That's a different noise. We go back and we do binomial CDF with x equals 11. And that gives us a value of 0.404. And we subtract those, so that's 0.596. Okay. Now part D, what is the expected value? Well, the expected value is the same thing as the mean. Pulling up the second page at the same time. This is 16D. So our expected value is same thing as the mean, which is n times p. Okay, so n is 20 times p, which is 0.6. So it's expected that 12 of these 20 individuals will be working part-time. That has the highest probability of occurring of the bunch. Right. Oh no, that's problem 14. Now I'm on problem 15. That probably just confused a lot of you. I apologize for that. Now I really don't like this question 15 because we did not study dice at all for the probability of outcomes on dice. The one on your test for number 15 here is almost exactly like the one that we did on our test 2, where we had 10 numbers in a hat. So basically they all have the same probability of 0.1, but you know, if there's 3 outcomes for the same result, then we know the probability is 0.3, and so on. It's just like what we did on test 2 for this same type problem. With dice, it gives us a lot more different probability. And this is not a bad question, but we just have not studied dice that much, and the one in the final exam is actually using the 10 numbers in the hat. So rather than going through this problem, I encourage you to look back at test 2 at the same question. Now, I do want to make some notes about creating our probability distribution. let's see, we have our outcomes, net winnings, which is x. We have our probability, p of x. And we like to have a fourth column, which is x times p of x. Okay. Now our net winning, or sorry, outcomes, we just list these out here in groups because we could pull the numbers 1 through 10 from the hat, but really there's only like 3 or 4 different scenarios. Like 1 through 3 gives us one outcome, 4 through 7 gives us a second outcome, and then 8, 9, and 10 gives us a third outcome, for instance. So we can list those kind of together, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However it breaks down. Our net winnings, be sure that we take the amount 1 and subtract the amount that we pay up front to play the game. So if we draw, for instance, a 1, 2, or 3, and we win $2, but we paid $3 to play the game, then -1 is our net winnings in that scenario. Okay. Now we know there's 10 outcomes total, and so that's 3 of the 10 outcomes, so 3 out of 10 means our probability of that happening is 0.3, and then we just multiply -1 times 0.3, and that gives us -0.3. Once we fill out this last column, we add these up, and the result is our expected value. Okay, so I'm not going to work this specific problem on the review because it's a lot more complicated because it's working with dice instead of like 10 numbers in a hat. That's really why I like 10 numbers in a hat, because it allows us to demonstrate our knowledge of the topic without getting bogged down in a lot of different calculations. Anyway, so I mean, you could look on the key to the review that I uploaded if you really want to see how the problem happens, how 15 works, and look at the specific numbers involved. But I think we can skip that for now. I'll just have you look back at your test 2 problem, because that's a better example, honestly. Okay, that wraps up test 2 material. Now we continue into test 3 material. That's where we are at 16. How many problems are in this thing? 24 problems. There's actually some others that we're going to skip later, though, so we're doing okay. Mostly. So 16, the average commute to work one way is 25 minutes, according to an American Community Survey. If we assume that commuting times are normally distributed and the standard deviation is 6.1 minutes, find, or what is the probability that a randomly selected commuter spends at least 30 minutes commuting one way? So our mean is 25 minutes. Our standard deviation is 6.1 minutes. And we want the probability of spending at least 30 minutes commuting. That's our x. That's our data value. So we take our Z-score formula, x minus mu divided by sigma. And we know to use this Z-score formula because we haven't been given a sample size. We know that we're looking at one individual person taking at least 30 minutes, and not a group of people taking 30 minutes to get to work. And that's going to be the key difference between those. Alright. So So we plugged in x is 30, mu is 25, sigma is 6.1. So we end up with 5 over 6.1. Which gives us a z-score of 0.82. Okay. You don't have to make a graph, but I think it does help. Papers are getting kind of weird here. The zero's in the middle, so 0.82 is in the right. And we said at least 30 minutes to commute. Means 30 minutes or more, so that is the area to the right. So our lower bound is 0.82. Our upper bound is 10, and we can go into the calculator and solve it from there. So we hit second data, go over to distribution. We want NormalCDF. And let's see, mean is 0, sigma is 1, lower is 0.82, and upper is at 10. Calculate. So we get a probability of 0.2061. So that's our answer there. A little bit better than 21% of the probability that a person would take more than 30 minutes in their commute. Which is probably fairly accurate if you're going from, if you live in Odessa, work in Midland, or vice versa, depending on where in the city they work and live. Okay. Now, we said, okay, we found 0.82 as our z-score, Ashlyn. So we know that we have this as kind of a key point. The question is, which side do we shade on from that 0.82? When we look at our probability, we said we're looking for the probability that at least 30 minutes is spent commuting. So when we say at least, we means that value or more than that value. Okay? So that's what tells us that we shade to the right. And so we use the 82 as the left side of that shaded region, so that's our lower. And because it just keeps going indefinitely, we like to use 10 as our upper bound on the right hand side. Does that make sense? Okay. Right. Moving right along. The mean lifetime of a wristwatch is 25 months, with a standard deviation of 5 months. If the distribution is normally distributed, for how many months should the guarantee be made if the manufacturer does not want to exchange more than 10% of the watches? So we have 3 key values here. 25 is our mean, 5 is our standard deviation, and 10% is the percentage that we're interested in. So mu is 25, sigma is 5, and we want the 10% value, which means the 10th percentile. And we'll actually use 0.1 in our calculator when we use that. But this one uses the inverse normal function on the calculator. Because we have mu, we have sigma, and we have an area value or a percentage. This is our probability that we want to find. So we have to actually have to find x. Now, we go second, data, distribution, inverse normal is our third option there. So our area is 0.10 because we're 10th percentile. That's our area. Our mean is 25, and sigma is 5. Calculate, and so we find that x is 18.6 months. Now, so that's how we get our answers. We got x is 18.6. But now we think about this logically. Can a company, or does it sound good if a company guarantees their wristwatch that it will last at least 18.6 months? You put that 0.6 on there, and people start to really think about what happens on the whatever the 21st day of that month. Is it going to break automatically? We don't know. And so it's more realistic to say, let's round down to 18 months. Now, the reason that we round down is the company did not want to exchange more than 10%. So if this value represents 10%, anything higher than that, if we round up to 19, would actually be more than 10%. And if we round down to 18, it would be less than 10%. So we have to think about this somewhat logically to properly answer this question. And as for a statement, I don't know what kind of statement we need to write there, so I wouldn't worry about that part too much. If it does ask it on the exam, I won't count off if you don't put a statement there. Alright, the average yearly Medicare hospital insurance benefit per person was $4,064 in a recent year. If the benefits are normally distributed with a standard deviation of $460, find the probability that the mean benefit for a random sample of 20 patients is between $3,950 and $4,100 per year. Now, these values are both sample means. This is the mean benefit for a sample of 20 patients is between these two numbers, 3,950 and 4,100. So each of those is x bar, and for this one we're going to use z equals square root of n times x bar minus mu divided by sigma. Since we're talking about a sample of 20 individuals rather than one individual like we did in problem 16. And we have two different x bar values, so we have to calculate this twice, one for each of these two values, whenever it says it's between two numbers. So for x bar equals 3,950, z is square root 20 times 3,950 minus mu, which is 4,064, divided by 460. So So we take root 20 times parentheses 3950 minus 4064, and then divided by 460. So that gives us negative 1.11. Negative 1.11. And then we repeat for x bar equals 4,100. So here z is root 20 times 4,100 minus 4,064 over 460. We only have to change that one value. And so I'll approximate this one also. 4,100 minus 4,064 divided by 460. So it gives us 0.35. Again, just go to 2 decimal places with their z-scores. Okay. Okay. So negative 1.11, positive 0.35, and we want the area between, so that means our lower is negative 1.11, and our upper bound is 0.35. It takes a little more work to find our values because there's 2 of them that we have to calculate for our z-scores, but those are exactly our lower and our upper always. For this between, if our question says between 2 numbers, like we have here. Alright, so we do normal CDF. Now, after we did problem 17, notice our mean and our sigma changed. We want this back to be 0 and 1, so make sure we fix that. And then we have negative 1.11 for our lower and positive 0.35 for the upper. Calculate. So we get 0.5033. And that's our probability that the mean yearly medical or Medicare hospital insurance benefit for a sample of 20 patients is between $3,950 and $4,100. That's a lot to say. I'm glad we don't have to make a statement on this one. But yeah, that's our probability right there. Slightly better than 50% chance. Gotta get moving here. That was 19? Oh, apparently I left off problem 19 on the review. Well, that's great. Let's go to 20 then. There is no 19. Sometimes these things happen. The growing season for a random sample of 36 U.S. cities were recorded, and a sample mean of 190.7 days with a sample standard deviation of 54.2 days was found. Now, since we said sample mean, we know that we use x bar. Sample standard deviation is 54.2. What is the best point estimate? Well, point estimate is going to be the sample mean here. I think it's kind of a silly question because, anyway. Now, what is estimate the true mean for the population of the growing season with a 95% confidence interval? So now we're in chapter 9. Now, notice we have S. We do not know the population standard deviation. Instead, we have the sample standard deviation. So our margin of error is going to be E equals T alpha over 2 times S divided by square root N. Same formula we just used on test 3. Now, for T alpha over 2, we use the degrees of freedom, which is n minus 1. Now, n is 36, so our degrees of freedom is 35. And 95% confidence. Now, for that one, we have to go to our table. How'd that go? For that one, we have to go to our table. This is on our formula sheet. So we pull that up. And again, this is the same instructions that we're using for this last test. So for confidence interval for the mean, our point estimate is x bar. That's what we just found. Our margin of error, if sigma is known, is this formula for E. And our margin of error, if sigma is unknown, is this formula for E. And this is one that we're using because we don't know sigma. We've actually been given S, the sample standard deviation. So we use the table on the next page. Now we said N or DF, degrees of freedom, is 35, which is right here. And we went 95% confidence. 95% confidence is this middle column. So we come down to 35 and across. So we use 2.030 for T alpha over 2. Is everyone okay with getting that value there? Okay. So now we have T alpha over 2. So we can calculate our error, which is T alpha over 2, 2.030. times S, which is 54.2, and then divided by square root of N, which is 36. So we'll just go to the calculator and find that. 2.030 times 54.2, and then divided by square root of 36, which is actually 6. And so we get our margin of error is 18.3. And this is days. Alright, the last thing they want us to find is the interval. Well, so the statement after that. Now our interval is x bar minus the margin of error and x bar plus the margin of error. So we take 190.7 minus 18.3, so it's 172.4, and then 190.7 plus 18.3, which comes out to be 209. Okay, that's our interval, and so for our statement, and it may or may ask us a statement, kind of like how I did on our test, where I made it a separate question from the problem. So we can say we are 95% confident the mean number of days in the growing season is between 172.4 and 209. And that's all we need for our statement there. Okay. Move forward. 21, this is a hypothesis test question. Oops. The average undergraduate cost for tuition, fees, room, and board for all institutions last year was $26,025. A random sample of 40 institutions of higher learning were studied this year and showed that the mean cost for the sample was $27,690 with a standard deviation of 5492. At the alpha equals 0.05 level of significance, is there evidence to show that this cost has increased? So, let's write down our numbers first. It's always step one. Let's make sure we extract our data from the paragraph. So we have mu is 26,025. Sample of 40 institutions, so n is 40. We have sample mean x bar 27,690. Ooh, sorry. Bumped the camera. And we had a standard deviation of 5492. And we have an alpha equals 0.05 level of significance. Now, this is what we talked about the last 2 days in our classes with our hypothesis test. So we start with our null hypothesis H naught, and that just states mu 26,025. And our alternative hypothesis, since our sample got a higher value, x bar, than mu, we think mu has actually increased, which is means it'll be larger than $26,025. Let me show you what I put on the formula sheet for this problem. Hypothesis test for the mean. And by the way, I said skip problem 18 on the final since we didn't have time to cover that. So when you get to it, just leave it blank. I'll give you credit for it and think of it as a way to boost your grade a bit. Our critical value is either alpha equals, depending on the alpha, we use a particular critical value, and it's positive or negative depending on if it's a left or right tail test. Now, and then we have our test statistic down here, and then our how we make our decision. So all of this is for this one hypothesis test problem. Okay. Because we're saying greater than here, we know that's a right-tailed problem. And since alpha equals 0.05, we know z equals 1.645. That's our critical value. Okay. So now we look at our test statistic. ZT is equal to square root of n times x bar minus mu divided by sigma. So we get square root of 40, and we get 27,690 minus 26,025 divided by 5,492. That's a lot of variation. Let's see. So root 40 times, and then we subtract. And then we divide by 5,492. So we get ZT is 1.91 or 1.92. It's 1.917, but remember Z-scores we round to 2 decimal places. So we'll say 1.92. Okay, so we look at our graph. Now our critical value is 1.645, and we know it's a right tail. We're shading to the right. And our ZT is actually to the right of that, 1.92. And so on the formula sheet I say we reject H0 if ZT is in the shaded region, otherwise we fail to reject H0. So ZT is in the shaded region, so we reject H0. Okay. And lastly, we want to summarize an answer, which says we have sufficient data at the alpha equals 0.05 level of significance to show that the cost of college has increased. Okay. All right, one more problem in 10 minutes. Now on the review, that was problem 21. 22, don't worry about that question. We didn't study how to do that one. That's a proportion with hypothesis test. Unfortunately, we didn't have time. 23, that's from chapter 11. That's way up, but that's not even on the exam. Now there's one on similar to 22 on the exam, and that's the one I told you to skip. It'll be alright if you don't recognize it. I'll just count it as correct regardless. 23 is not even on the final, so don't worry about that. Okay. So our last problem is 24. And this is on linear regression. Now we spent one day, I believe, maybe 1.5 days between. This is chapter 4, so it was right after test 1 that we did this. First thing they want us to do is fill in the missing blanks here. So this column, for instance, is calories squared. So we'll take the calorie value, 180, and square it, and write the result there. So we'll just go to our calculator and say 180 squared. So 32,400. So we'll fill in this value with 32,400. Same thing down here. This will be 190 squared. This blank, this is sugar squared. Sugar is 12, so we'll do 12 squared, which is 144. And then this one's 11, so this is 11 squared, 121. And then calories times sugar up here. Just multiply those two numbers together. 210 times 23. Fill it in. Same thing down here. Fill it in. I think that part of the question is a little bit silly, but it just makes sure we understand we can read the table correctly, I guess, which is not bad. Anyway, so that's part A, is just fill in those missing blanks. Now, we don't even need to fill in those blanks to answer the rest of the questions, though. So we want to calculate the correlation coefficient and find the linear regression equation. Now, on our calculators, this is where it gets a little tricky. We have to enter calories and sugar in two different columns. So on the 36, for instance, we press data. We bring up our two lists. I'm going to go ahead and clear out this first one. Just delete every value here. So in column 1, I'm going to put calories. And in column 2, I'm going to put sugar. So 200, 210, 170, 190, 200, 180, 210 three times, 190 twice, and then 200. This last row, it doesn't say it on this table, but it says it on the final exam. This last row is the sum of the columns, so we don't need to enter this last row, 2360, 205, etc. That's just the sum of all these numbers above it. Okay, enter column 2. We have 18 grams of sugar, 23, 17, 20, 18 and 19, 23, 16, 17, 12, and then 11 twice. Okay. So we've got everything entered in. Notice that both columns have 12 items. We want them to have the same number of items. That means we haven't missed anything, which is great. Now on to 36. To get the correlation coefficient and the regression equation, let's see, we go second, data. Now we stay on the stat reg, which is, oh, here it is, linear regression. It's right under the stats. Now notice that this is AX plus B. That's important. We could also use nope, we just want to use that one, sorry. On the bigger graphing calculators, you have two options, AX plus B or A plus BX. Make sure you notice which one you're using so you write down your answer correctly. So we press linreg AX plus B. Our X data is in list 1. It's highlighted there. Y data is in list 2. Notice in the table it said calories is X and sugar is Y. Frequency is just 1. I don't know what that is, so let's just leave it off. And calculate. Okay. Now, we need 3 numbers here. We need A, we need B, and we need R. Let me write this down. So for 24, A, we came up with 0.082. This is y equals ax plus b. B is 0.929. So our regression equation, which is actually the answer to part C, is y equals 0.082x plus 0.929. Now for B, this is the correlation coefficient, and we have to arrow down. There we see R, 0.26. This is our correlation coefficient. And then, very last question, D, interpret your finding. Well, this is based on R. It's less than 0.3, so it's a weak positive correlation. Now, I did not include those values for weak or strong correlation values. Weak is less than 0.3, strong is greater than 0.7. I forget what we called in between. You can just call it normal. And it could be positive or negative, depending on the values. But yeah, that's all we have to do for the interpretation part, and that's the last question on the quiz there. Do you all have any questions? I put the project grades in Canvas already, I believe. Let me look real quick. Which question, Ashlyn? We definitely want to do this 24. We've talked about that in class before, and I think we can do it. Yeah, the one like 22, which is actually problem 18 on the final. You can do it, or well, you'll probably look at it and you'll say, I don't recognize this at all, because we didn't cover it. And so you can just skip it. I did enter it, Jacqueline. Let me look at Haley. Oh, never mind. I know which section you're in. I'm going to look at the grade book real quick since we're here. Now, Haley, I didn't put your grades in because I didn't think I had your grades. Because I went through all my email and figured out who sent me those, and I included it. Now, it is possible I missed it. If you still have it, it might be worthwhile to send it to me again. And make sure you send it from the Mellon College email, like through Canvas, rather than from a personal email, because sometimes the personal email gets caught up in our spam filter, which is regrettable. Yeah, I'm not seeing anything from you, Helium, sorry. But if you did, definitely send that to me again, and I'll enter those in. No, that's okay. I mean, sometimes the mail system is unreliable. And like I said, make sure you send it from a Mellon College email. That's the only way to guarantee it'll go through. Or through Canvas. And I'll look through my email, but I didn't have anything from you in there, unfortunately. I'll look through it again though. Okay. Well, I hope you all had a good semester, and I appreciate your showing up this morning. The 10 or 12 of you that showed up, which I appreciate. And I know the rest of you will hopefully be watching this a little bit later, just to make sure you're okay with this. So I do hope this was helpful and prepares you well for the exam. Any other questions before I wrap it up? I'm a little late for my meeting, but honestly, I didn't want to go to it anyway. But I had to go to it. Yeah, absolutely. Again, I wish we could have done this class in person, because I think it'd be a lot more interesting, and we could have done more group work and just some different things that we don't really get to do online. But I hope it was a good experience overall, and hope we get through this okay. So you all take care. Good luck on the exam, and if you do have questions or anything else, or if you have other work to turn in still, you can still send it to me before next Wednesday, or through next Wednesday. Anything after Wednesday will be disregarded. I'll just say that. So, okay. Yeah, y'all have a good holiday too, and take care.